Good afternoon. Brad Buckman, Principles of Public Speaking, March 2013, Persuasive Speech. Good afternoon. I encourage any aircraft owners or potential aircraft owners in the audience to consider the following presentation for their next purchase of an aircraft engine, whether it's a turbine or reciprocating aircraft engine. Three things we're going to focus on are efficiency of the engine, the power available, and the maintenance cost between the engine. Starting with the standard aircraft four-stroke reciprocating engine, this is a breakdown of the actual engine itself. It has several moving parts compared to a turbine engine. You're looking at, you've got a piston which slides up and down inside of the cylinder. This is the cylinder wall here. This is the actual cylinder itself. Connecting rod which connects to the crankshaft, and that crankshaft will then turn the gearbox, which will turn a rotor head or will turn the propeller. Four-stroke engine consists obviously of 4 strokes. You've got an intake stroke. This intake valve will move open, air will come in. You're then going to have the compression stroke. The compression will come up, squeeze it together. At the top of the compression stroke, the ignition source will ignite and you will have combustion. This is going to shoot back down, and that is also your power stroke, and then your exhaust stroke. This exhaust valve will open up. Each cylinder is it's only 25% efficient because it's only producing power 25% of the time during its 4 strokes. So again, it's far less efficient. It has several moving parts. The piston and the connecting rod itself, they're exposed to impact forces. It's a constant, every 1 in 4 turns, it's exposed to an impact force. That explosion that happens up here, which connects to the piston down to the connecting rod and to the crankshaft. The ignition source is required for every single stroke. That's another thing to consider. With the turbine engine, the ignition source is only for the start. Once the start is self-sustaining on a turbine engine, it no longer needs an ignition source. That's another benefit of a turbine engine. Less fuel consumption, but you're going to go half the distance or even less. 10 gallons per se on a standard Cessna Skyhawk engine will take you about 100 miles. Onto the turbo shaft engine. Far less moving parts. The basic parts of the turbine engine. We're looking at the axial compressor, which turns the gas generator. This is the combustion can here. This is where the explosion happens. It's turning the free power turbine here, which turns the reduction gearbox again, which is connected to a rotor head or a propeller. The only need for spark in this engine is for ignition, as we talked about before. Once this compression and combustion reaches a certain temperature and speed, then it no longer needs ignition. All it needs is the compression of the air with fuel, and you'll have a non-stop combustion in there, like a never-ending balloon, if you will. It's over 90% efficiency because it's a never-ending compression, non-stop power, and it's much greater fuel consumption. Something in this standard engine like this, you'll burn anywhere from 40 gallons per hour, but you're going to be going anywhere from 300 to 400 miles per gallon, which is about the same as a Cessna Skyhawk. It's burning 10 gallons to 100 miles over the ground, 10 miles to the gallon. Same with this, 40 gallons per hour and 400 miles per se. So you're looking at 10 gallons either way, 10 gallons 10 miles per gallon. On to our next topic, the power available. Your standard Cessna Skyhawk engine weighs about 250 pounds. It puts out about 160 horsepower. The power to weight ratio on that is 1 pound of engine to 0.64 horsepower, which is not very much. Your turboshaft engine puts out it's about 300 pounds, it puts out around 1,200 horsepower. So you're at 1 pound of engine for every 4 horsepower it produces. Difference in altitudes for your performance and your power available. Reciprocating engines can operate at high altitudes, but the air is less dense up there, and it results to basically less efficiency with the engine. because of less oxygen and less dense air. The turbine engine, however, because of that axial compressor, it has its basically in-house capability of compressing the air, so you never have to worry about less dense air or the oxygen content as well. On to the maintenance costs. Maintenance costs, time between overhauls is a big key for any aircraft engine. Any aircraft mechanic will tell you that. Four-stroke reciprocating engines, typical time between overhaul is every 2,000 hours on the engine. The average cost of an overhaul is about $20,000. With the turboshaft engine, you can put at least 3,000 hours on most of them, some of them even more, before it has to go in for overhaul. And the standard cost is around $20,000 or maybe a little more. So if you break it down, you're looking at 6,000 hours on a reciprocating engine. It's going to give you $60,000 overhaul cost. Well, if you spend that same $60,000, if you buy a turbine engine, you're going to get 9,000 hours on that. If you're able to fly more, you're able to make more money. If you're renting out your aircraft, or if you're just up for pleasure, you're going to get more flight time in regards to the $60,000 per se that you're spending on your maintenance costs. In conclusion, the turbine power aircraft are without question a better option because of the efficiency, because of the power available, and because of the maintenance costs. If you can get yourself over the initial hurdle of the upfront cost, which is it's gonna be considerably more than a reciprocating engine, but in the end you'll find yourself much happier because of that power available. You'll enjoy the power when you need it on takeoffs and landings. If things go wrong and you need that power, I guarantee you'll be saying that you'll be thanking yourself and thinking, if you listen to the speech and pay attention to it, that you took the advice and went the extra dollar when you first bought that engine to have that power when you needed it. References for the speech, got all the information from nasa.gov and faa.gov.